Hi students, this is AJ sir. Let's study 9th standard ICSE Math chapter 28 distance formula. It's the last chapter of 9th standard, so if you've survived till here, then congratulations and gear up for 10th standard. Those who would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information. Now, in a graph, if you are given any 2 points and if you are asked to measure the distance between them, you would probably count the number of boxes between them. So it's convenient to measure the distance if the distance is parallel to either of the axes. That is, I can easily measure the distance between A and C or between C and B. I just have to count the number of boxes if it was a graph. But what if the 2 points given are inclined to the axis? For example, AB. Now there we can't just count the number of boxes. Yes, we can use a ruler to measure the distance. But in this chapter, we will study a formula using which we can find the distance mathematically by calculation. And that formula is AB is equal to x2 minus x1 the whole squared plus y2 minus y1 the whole squared and the square root of that. There is a Pythagoras theorem involved in its derivation, but we just have to learn this formula. This entire exercise and chapter is based on this formula only. There is nothing else to it. It's very simple. So assuming that A's coordinates are x1, y1 and B's coordinates are x2, y2, we can substitute the values of the coordinates in this formula to get the distance. The x coordinate is also called abscissa and the y coordinate is also called ordinate. So remember these terms as well. Also, it really doesn't matter whether you take these coordinates as x1, y1 or these as x1, y1. Even if you interchange these variables and substitute it, you will get the exactly same answer. Let's solve a sum to check it. So we start with question 1.2. Cancel question 1.1. It's too easy and of the same type. So to reduce your homework, you can cancel it. 1.2. The 2 points are given. The coordinates are given. So since this is the first term, I'm going to use a little longer method. First I will say that let x1 comma y1 be equivalent to minus a and minus b. That means this is x1 and this is y1. Similarly, I'm assuming this as x2 and this as y2. Now this is the distance formula. Substitute x2. What was x2 by the way? It was a, isn't it? So substitute it as a. Minus, so you can write minus sign. And what was x1? It was minus a. So this comes out to be a minus minus a. And minus minus becomes plus. So I have directly written it as a plus a and of course the whole squared. Similarly, this is b minus minus b, which I wrote directly as b plus b the whole squared. Be very careful about signs in such sums. Now this becomes 2a squared plus 2b squared. That's square is for everything in the bracket. So 2 squared is 4 and a squared will write it as it is. We can remove 4 common, so do that. And what is square root of 4? It's 2. So write 2 and the umbrella goes away here. But a squared plus b squared, we can't solve it further. The umbrella will remain. No, it won't become a plus b. There is a plus sign here. So we can't remove the square root of this. This is the final answer. But what if we had interchanged the variables? What if we called these as x1, y1 and these as x2, y2? Would we get the same answer? Let's find out. So let me substitute x2 as minus a. So this will become minus a plus a. No, minus a the whole squared plus, and this will become minus b the whole squared, and of course square root of that. Now minus a will be minus 2a the whole squared, and minus b will be minus 2b the whole squared. However, when we do a square of any negative number, notice that the negative number is inside the brackets, not outside. So then this will become positive. So ultimately we'll get the same answer. That is why there should be no confusion about which one is x1, y1 or x2, y2. It doesn't matter in any sum. Now let's do Roman number 4. So x coordinate comma y and x coordinate comma y coordinate. 2 points are given and we have to find the distance between them. So now no need to write the formula. We will directly substitute it. Here I'm not going to take this as x1, y1. I will take this as x1, y1. So I'll do it as root 3 plus 1 minus 0 the whole squared and 1 minus root 3 the whole squared. If I would have written it in the other way around, like 0 minus root 3 plus 1 the whole squared, as you know, the answer would still be same. But I chose not to do that because then I would have to be very careful about the sign. See, if I write 0 minus root 3 plus 1 and the whole squared. So when I open these brackets, the root 3 plus 1 will become 0 minus root 3 minus 1. So if you can remember that the sign has to be changed, then you can do it that way as well. But I chose to do it this minus this the whole square and this minus this the whole square, and of course square root of the entire thing. Even in the formula, you know, if I would have written it as x1 minus x2 the whole squared and y1 minus y2 the whole squared, still the answer would have been the same. It really doesn't matter which comes first and which comes second. But of course you can't have x2 minus x1 here and then y1 minus y2 here. No, that would be asymmetrical. So now minus 0, so that's irrelevant. It's basically root 3 plus 1 the whole squared. That is a plus b the whole squared is a squared plus b squared plus 2ab. So that's 2 root 3. Yes, root 3 squared is 3, of course. Plus, again, a squared plus b squared minus 2ab. So again I get this. Interestingly, 2 root 3 and minus 2 root 3 gets cancelled. 4 plus 4, 8. This can be simplified further. So you have to do it. You can't leave the answer like this. So think about it. What would you do next? Well, always we do prime factorization if you can't do it mentally. So this will be 2 into 2 into 2. I saw a pair of 2's here. So there is a square root sign. So the pair comes out and the umbrella goes away on top of it. So 2. But poor guy, this 2 is all alone. It will have to stay under the root sign. So 2 root 2 is the answer. 2 root 2 unit. Always write units for every sum. There is no centimeter or meter in this exercise. Next, 2.1 is cancelled. Let's do 2.2. Find the distance between the origin and this point. Well, when they say origin, we know the coordinates of that. It's 0, 0, and this is the point given. We have to find the distance. The formula is known. So this time I'm going to do 8 minus 0 the whole squared and minus 15 minus 0 the whole squared. So this becomes 8 squared plus actually 15 squared. It's minus 15 squared, but hey, minus 15 squared is nothing but 15 squared, right? So we get the final answer as root 289, that is 17. We should have known this. 8, 15, 17, these are Pythagorean triplet. Next, the fourth sum. Find the coordinates of the points on the x-axis which are at a distance of 17 units from the point 11, minus 8. Let us try to understand this sum by visualizing it on a graph paper. This is the x-axis, this is the y-axis. So there is a point called point 11, minus 8. In which quadrant would it lie? It would be somewhere here. Yes, 11, minus 8. I hope you all know how to plot points on a graph paper, which you will do in chapter 26 and 27. And they said that there is a point on the x-axis, somewhere on the x-axis. Let's assume that the point is out here. So the question is, if the distance between them is 17, the distance is given, what are the coordinates of this unknown point? By the way, you should know that any point lying on the x-axis will have the y-coordinate as 0. Always remember that. If there is any point which lies on the x-axis, its y-coordinate, which is also called ordinate, is 0, and the x-coordinate, which is also called abscissa, is unknown. So let's call it x. So now the question is simple. These are the 2 points. Distance is given. Find the value of x. So let the point on x-axis be x, 0. Distance is known. Use the formula. This becomes, you have to open the bracket, so it becomes a squared plus b squared minus 2ab. Solve it further. Get rid of this root sign now by squaring both the sides. That's the only way we can get rid of it. Send 289 on the other side, so 0 will remain here. This becomes a quadratic equation. So we'll have to do splitting the middle term, which you are an expert in. 22. Well, do the find out the prime factors of 104 such that the addition or subtraction gives you 22. Do not just copy from here. Try it on your own. You need practice. No, I was being sarcastic when I said you are an expert in this. Don't take it literally. So the combination seems to be minus 26 plus 4, because multiplication will give you minus 104 and their addition will give you minus 22. So that's a perfect match, sign wise as well. So here again, these two terms, x is common, this remains in the bracket. Here 4 is common, x minus 26 in the bracket. And obviously the brackets are always same in such a method. The bracket comes out again common. What is left behind? X plus 4 in another bracket. Their product is equal to 0. That means either this is 0 or this is 0. That means x is either 26 or x is minus 4. So you got two values of x. That means the required point is either 26, 0 or minus 4, 0. Which makes sense. Even in the question they had said find the coordinates of points. So that was a good hint. And even if you visualize it, it is possible that there are 2 points with distance 17. One point could be here somewhere and the other point on the other side. In fact, I see a negative number in the answer, so it will be out here. So both the answers are possible. Understand that here we can accept the negative value of x because it is not a distance, it is just a coordinate of a point which can be negative. Now the sixth sum. A point is at a distance of root 10 units from the point 4, 3. Find the coordinates of the point if its ordinate is twice its abscissa. Okay, if the ordinate is twice the abscissa, then let's assume the point to be x, 2x. and the distance is given. So all we have to do is find the value of x. Distance formula, substitute the values, open the brackets using the formula, like terms together, squaring both the sides to get rid of the root sign, rearrange the terms, get a quadratic equation. Don't do splitting yet. If you can divide the equation by a number, do it. Don't deal with big numbers unnecessarily. All these coefficients are divisible by 5, so divide the whole equation by 5. Dividing by 5, mention that. And now splitting the middle term, 4x will become minus 3x minus x, and the product is also plus 3, so perfect match. And then of course these two terms, x take it out common, here minus 1 is common. When nothing is common, we take out minus 1 common, and what is left will be x minus 3. Yes, minus, the sign will change because outside there is a minus sign. If you open the brackets, again you will get this. The brackets are same, take it out common, what is left is another bracket. So again we get two values of x here, and if x is 3 and 1, then the 2x will be double of these. So the required point is either 3, 6 or 1, 2. Now the 8th sum, it's an IMP sum. What point on the x-axis? The moment they say the point is on the x-axis, what comes to your mind? That the y-coordinate is 0. And it's said it's equidistant from this point and this point. Okay, we should draw a diagram to visualize this. So this P is lying on the x-axis. Imagine an x-axis passing through P. So the y-coordinate is 0, x-coordinate we don't know, but we do know that AP is equal to BP. So using this, we can use distance formula, find PA's value in distance formula, and BP also distance formula, 2 points. Open the brackets. The square root signs will go away when you square both the sides. Interestingly, x squared and x squared got cancelled, so no splitting the middle term in such sums. Directly get the value of x, and the required point is 3, 0. Now the 10th sum. A point P lies on the x-axis, that means y-coordinate is 0. Another point Q lies on the y-axis, that means its x-coordinate will be 0. Write the ordinate of point P, I just said it, it would be 0. Roman number 2, write the abscissa, that is the x-coordinate, of point Q. Well, it's lying on the y-axis, right? So its x-coordinate has to be 0. Whenever you have, check it out in a graph, if you have a point on the y-axis, definitely its x-coordinate is 0 and the y-coordinate will be some number. So that's the answer for Roman number 1 and Roman number 2. And then they have given the other coordinates of P and Q, and they've asked us to find the distance between them. So that's pretty straightforward. P is minus 12, 0, Q is 0, minus 16. Using the distance formula, now be careful. So I'm doing 0 minus 12 the whole squared, minus 16 minus 0 the whole squared, and the whole square root. 0 minus 12 is positive 12 whole squared is 144. Minus 16 minus 0 is minus 16 the whole squared, minus sign goes away, again positive 256. And the square root of that, guess, ready to see? It's 20 units. That's the final answer. Next, the 12th sum. It's an IMP sum again. Mark it as IMP. 4 vertices are given. We have to prove it to be a rectangle. Okay. 4 vertices are given. I purposely not made the right angle sign here because we have to prove that it is a rectangle. Right now I can only say that it's a quadrilateral. When is a quadrilateral a rectangle? When the opposite sides are equal. Yep, we can do that. We can prove that. But that would be sufficient. That would just prove that it is a parallelogram. One more criteria has to be satisfied. How about proving the diagonals equal as well? In a normal parallelogram, the diagonals are not equal. If they are equal, then it has to be a rectangle. So let's do that. Let's find the value of PQ, QR, RS, SP, all four sides using distance formula. And no need to solve it further because we don't have to find this, we just have to prove that the opposite sides are equal. So we do see that they are equal. PQ is equal to RS because both are equal to root 72, and QR is equal to SP, both are equal to root 18. So we have proved opposite sides equal, so that's a parallelogram. But that's not enough. Now we'll find the diagonals as well, PR as well as QS. The points are given, so just use the distance formula. Do not just copy, try to solve it on your own and check the answers. And since the diagonals are equal and the opposite sides are equal, hence it's a rectangle. Such an easy sum, a long sum, but easy. Next, the 13th sum. Now here 3 points are given, and we have to prove it to be an isosceles right-angled triangle. Well, to prove a triangle isosceles, I just have to prove any two sides equal, and we can prove a triangle right-angled using the converse of Pythagoras here. So let's do it. First, distance formula, find the value of AB. Be careful with the signs. I got 5. AB is 5, BC is root 50. Don't solve it further. If you do, it's okay. You'll get 5 root 2 as the answer, which is clearly bigger than this. So this seems to be the hypotenuse of the triangle, the biggest side. And AC is also 5. So clearly two sides are equal. AC and AB are equal. That means it's an isosceles triangle. But how to prove it as a right angle triangle? Well, if you take the sum of the squares of the two smaller sides, it is equal to the square of the biggest side. So by converse of Pythagoras theorem, it is a right angled triangle, and the right angle is at vertex A. And please read the question carefully. They have asked us to find the area also. Often we forget the last part of the question, which I did as well, but then I realized, so now area of a triangle is half into base into height. A hypotenuse is neither the base nor the height, so it's half into 5 into 5, that is 12.5 unit squared. Please write here by converse of Pyth theorem. It's important to write this. Now the 17th sum. Cancel the 15th sum, it's too easy. Just prove all sides equal. 17th sum is IMP, it's a unique sum. The 3 vertices are given and they want us to find the circumcenter. Understand that circumcenter is not centroid or incenter or orthocenter. Those are things which you will study in 10th standard. But circumcenter basically is a point, is a center of a circumcircle. Circumcircle is a circle touching all 3 vertices of a triangle. And we derive it by drawing perpendicular bisectors of the 3 sides, which you will study in a chapter called construction. One property of a circumcenter is that it is equidistant from the 3 vertices, because OB, OC and OA are radii of the same circle. So that's how we will solve it. So the 3 points are given. We know that we can assume the circumcenter to be x comma y, and we know that OA is equal to OB is equal to OC, radii of the same circle. That's a property of a circumcenter. So we'll solve OA is equal to OB out here and OB is equal to OC out here. We can do it one below the other as well, but I'm doing side by side. We could have used OA is equal to OC as well instead of this, but this will be very useful. I'll tell you why soon. First of all, OA is equal to OB. Well, distance formula, OA distance formula is x minus 5 the whole squared plus y minus 1 the whole square and the whole square root. Similarly, OB distance formula, get rid of the square root sign first of all, squaring both the sides. And now the only thing we can do is open the brackets. A squared minus 2ab plus b squared, again a squared minus 2ab plus b squared, and the RHS we've solved it here. Fortunately, x squared are getting cancelled. Even y squares are getting cancelled. Get the x terms together, get the numbers together, and get some linear equation and get the value of x. This is normal algebra. So please do it on your own, don't copy. Similarly, we'll do the same thing for OB is equal to OC, distance formula, and squared root sign goes away by squaring. And the best part is here the entire term gets cancelled because it's the same term. That is why I took OB is equal to OC and not OA is equal to OC, because I wished to get rid of this, making the further calculations far simple. Even here y squared gets cancelled and y is equal to 5. So we got the value of x and y. That is the point called the circumcenter. Now cancel the 18 sum, very easy. Let's go for the 20th sum. There's a center of the circle and the circle passes through a point -3, -1. Diameter is also given. Always draw a diagram, it makes it very easy to solve the sum then. The center of the circle, they are given, but we don't know the value of x. It passes through point A, whose coordinates are given, and the total diameter is also given as 20 unit. OA is a radius. How much will that be? 10 units, half of diameter. So now the sum is easy. OA, use distance formula, -3 minus 2x minus 1. So -3 minus 2x minus 1, but when I open that bracket, this sign will change. So I wrote 2 minus 2x plus 1, the whole squared. So be very careful about the signs. If you're not comfortable, then do the other way around. Do it 2x minus 1 minus -3. That is 2x minus 1 plus 3, the whole squared. Either way, you have to be careful about the signs in this sum. By the way, OA distance we know it's 10. And this also is a square. Squaring both the sides, get rid of the square root sign. -2 minus 2x squared. That is a plus b the whole squared actually. Now we could have removed minus common and the minus would disappear because of the square sign here. Or you can just do the normal a plus b the whole squared. -2 the whole squared is 4. Yes, positive 4 because there's a square here. Plus this the whole squared is again positive. Plus 2ab. Since both are negative, when you multiply them, obviously the answer will be positive. Same thing here. Everything is positive here thanks to the square sign here. Get the like terms together, you get a quadratic equation. Shift the 100 to the RHS, only 0 is left here, and we get this quadratic equation. Can I simplify this further? No. So let's start with the splitting the middle term, which is quite challenging here. First of all, we've got 13 into 92. That is the product which has to be prime factorized. So there are many possibilities here. 13 into 92 is one of them. How about 26 into 46? Even their product would be the same. And you can make a list of the various possibilities such that their multiplication is the same as 13 into 92 and the addition is 20. Fortunately, here itself I can see that their addition will give me 20. Of course, the sign will be positive 46 and minus 26. So the product will be the same as 13 into 92. In the earlier sums, there was no coefficient next to x squared, so it was quite easy. But here there is a coefficient, so you can't ignore it. You have to multiply it with the last constant term, and that number has to be factorized. So the splitting is 46 minus 26. Take x common here, take -2 common here, brackets are same, remaining terms here. So either this is 0 or this is 0. So 13x will be equal to -46, 13 goes down, so x is equal to -46 upon 13. In this chapter, no need to convert it into mixed fraction, or x is equal to 2. So I got two values of x, and that was the question. Find the value of x. Next, the 22nd sum. Here the value of p is given. The coordinates of p is given, and the coordinates of t is also given. So we can find pt by distance formula. So do that. pt distance formula 5 units. Always write units. Also, the radius of the circle is given. That means PA value is given 13. So if PA is 13 and PT is 5, how much will be AT by Pythagoras theorem? 12, isn't it? So that's how we find AT. That's Roman number 1. Don't forget to write sub question number, Roman number 1. What about AB? Well, if you look at the diagram, AB has to be double of AT. But how? We should write the reason. Well, there are many ways to prove this. First of all, you can prove the two triangles congruent. So you can say AT is equal to TB by CP, CT, and T is a midpoint. That is why AB is double of AT. But there's a simpler way. Remember, in any circle, if you draw a perpendicular to the chord from the center of the circle, then the perpendicular to the chord will bisect the chord. That's the property we will use here. Perpendicular from center of a circle bisects the chord. So obviously T is a midpoint and AB will be double of AT. 24 units is the answer. Next, the 24th sum. Calculate the distance between A and B. Now, they are saying that B is lying on the x-axis. That means the y-coordinate is 0. And its abscissa is 11. So, great. So, the B's coordinates are actually 11, 0. So, indirectly, they've made the sum very simple. A's values are given, B's coordinates are given. Find the distance by distance formula. Done. Answer is 5 units. And finally, 26th sum, mark it as IMP. Find the point on the y-axis, that means its x-coordinate would be 0, whose distances from points A and B are in the ratio 1:2. Let's draw a diagram to understand this. So there is some point, I'm calling it C. It lies on the y-axis, so obviously x-coordinate will be 0, and the y-coordinate I don't know, so just write y. And its distance from A is less than its distance from B. In fact, the ratio of the distances is 1:2. That means CB is double of AC. So that's what we are going to use to solve this sum. CB is double of CA because they had said that CA upon CB is 1/2. CB, use the distance formula. CA, use the distance formula. Open the brackets. This, I guess, all the minus signs will go away. Yep, and even here, 2 remains outside the root sign, of course. In the end, when we can't simplify it further, make sure you square both the sides. But that will get rid of the square root sign, but also the 2 will become 4. Don't forget that. And please put brackets out here because the 4 will be multiplied by everybody. Do not discriminate and multiply it only with 85 and neglect these people out here. So now open the brackets, distributive multiplication, get the like terms together, it will become a quadratic equation. Splitting the middle term, well, 3 into 35 is 945. So you'll have to actually find all the factors of 945 and check out various possibilities, which turns out to be 27 into 35 because their addition will give me minus 62. Yeah, both are minus, so the answer is also minus 62, and the product is 945 indeed. And then take 3y common, and the brackets are same, so take it out common, remainder here, get the 2 values of y. Yeah, 2 values of y. So the required point is either 0,9 or 0,35/3. So the only challenging thing is the calculation part. The methods are very easy. Splitting the middle term, well, do it on your own, do not copy.